Well, Dinara and I have real first-hand experience of using cables in Central Asia. When we both worked at Integra and our subsidiary Azimuth in Kazakhstan were shooting two of the biggest 3D surveys in Kazakhstan in 2009, we had to use cables, and this was over quite difficult terrain over the Karachaganat field and over the Tengiz field. And we had to ship a lot of equipment from Russia for the subsidiary to be able to do that. And I think that highlighted two things to me. The first was the logistics of moving large volumes of equipment, not only within Kazakhstan, but between Russia and Kazakhstan. Weight, cost, everything. And then the second thing was, especially for the Karachaganat crew, we had almost like a football-sized field camp to be able to accommodate all the cables, all the associated maintenance equipment, crews, etc. for that. And it just became a very challenging operation to manage and put severe strains on both being able to deliver within a short operational window and maintain the cost of the project. We also had some experience of shooting quite complex 2D surveys in Uzbekistan through urban areas, agricultural areas, and into mountain terrain. And this sometimes caused challenges with thefts, with just moving through populated areas. And again, that slowed operations, meaning there were cost pressures, but also meant there were a lot of non-productive time as we tried to replace equipment that had been stolen or damaged during the operation. There's no doubt to me that flexible, more smaller nodal systems that are available now would have made a dramatic difference both to efficiency and cost of those surveys back in 2009. Having worked with Stride technology over the last 7 years, it's clear to me that we are revolutionizing land seismic. There's been a lot of advancement over many years in marine technology of high density seismic, delivering high quality images and more efficient operations. And we've never been really able to achieve that on land seismic. I think the Stride system is really benefiting not only in oil and gas projects, but a range of industries and academia who are looking for avoidable subsurface imaging to answer specific questions and risk in the subsurface. I think for me, the system provides, or nodes provide, three key things. The first is greater flexibility in both 3D and 2D seismic survey designs. If you can use nimble, lighter nodes to densify in the receiver domain, you can be far more flexible in how you shoot and optimize source density to make surveys more efficient and reduce costs on the overall operation. So greater flexibility for me is one of the key benefits. The other that I mentioned, some of the challenges we had is nodes are more compact, the associated equipment, the support crews, the number of people are far more less intrusive than they are with cable systems. And this is allowing the deployment of receiver grids in urban areas or in agriculture areas without the need for a large amount of disruption, damaging the environment through things like line clearing operations. And this ultimately leads to reduced HSE risk now on land seismic surveys, with less people around, less vehicles around, and obviously less preparation on the land as well. The final one for me is very much the increased operational efficiency that we're seeing with nodal systems without compromising data quality. Before, on land seismic surveys, we've always had to limit the amount of equipment, limit the amount of people because of tight budgets. Now with the lighter nodal systems, we just don't have that. And we can get high density nodal surveys delivered much quicker It's much easier to deploy and retrieve those than they are to compared to cables, and they require no line checking as they're continuously recording, and this ultimately reduces one of the biggest factors on land seismic in terms of cost, which is the significant NPT, or non-productive time, that you have with line checking and replacing damaged equipment. So for me, we are seeing significant operational efficiencies, which ultimately leads to lower cost, which ultimately leads to quicker time frame of delivery of surveys. You're right. The high density is improving subsurface imaging, and I think people tend to think of it as high density just means greater sampling of the signal in the subsurface. But actually, what we're seeing with stride systems, because we can deploy in great densities, not only on 2D and 3D, we're able to sample the noise as much as we can, as well as we can sample the signal, and that helps with removing the noise within the processing and giving a much better signal to noise ratio within the final data. Not only is our system designed to deploy the high density in the field, but we're also our systems are very good at rapidly downloading data and recharging receivers with minimal manpower, which gives a much better understanding of how the survey data is being acquired, how quickly we can optimize operations as we move forward, and ultimately improve the dynamic rolling of seismic surveys. I think the other thing about our node is it's almost what I would term as no limit seismic acquisition. Again, previously with cable systems, because of the complexity, we've always had to limit the offset or the azimuth of surveys into what one would describe as active spreads. With our continuous recording stride nodes, you can deploy vast amounts of nodes on the surface and record long offsets, wide azimuths in the subsurface, with no need to limit anything, and ultimately select the most useful data within the processing sequence. And I'm pretty sure that the no limit seismic that we're delivering in terms of offsets and azimuths will certainly help Central Asia operators not only understand the deep complex geology that they have, but also doing some of the more high-end geophysical analysis like attribute analysis with wider azimuth data. We're also showing through the experience of numerous customers now across the world that Stride's ability to record and handle and process high density seismic is reducing the project cycle times, which helps with informed decision makers by operators in a much quicker and a lower cost environment. This is being demonstrated not only in oil and gas projects, but across a number of industries like mining, CCUS, even down into academia with architectural analysis of the subsurface.